December 1943, in the skies over occupied Europe, a heavily damaged Republic P-47 Thunderbolt, its Pratt & Whitney R2800 double Wasp engine belching black smoke, struggled to maintain its course as it staggered. Captain John Crash Henderson of the 56th Fighter Group, the Wolfpack Fighter Squadron, had fought valiantly through a fierce engagement with Messerschmitt Bf 109Gs over a dense forest in Belgium. His P-47, nicknamed the Jug for its size and rugged appearance, bearing the serial number 4226639, had taken heavy hits. Fortunately, Henderson successfully managed to bring his dying aircraft to an emergency landing in a nearby field, surviving the landing but quickly being captured by German forces. However, this particular P-47 was about to begin a unique journey, one that would force experienced Luftwaffe test pilots to reconsider their assumptions about American engineering and capabilities. The Thunderbolt lay relatively intact in the Belgian field and was soon recovered by German salvage teams. These teams had become adept at the systematic recovery of downed Allied aircraft across occupied Europe. Within a few weeks, this specific P-47 would be transported to Rechlin, the Luftwaffe's main testing facility, about 100 kilometers northwest of Berlin in Mecklenburg. Here it would be repaired, using parts salvaged from other, less repairable wrecks scattered across German-controlled territory. The aircraft would emerge with German markings, its fuselage bearing the Luftwaffe code T9+FK, its tail and undersides painted a bright RLM-04 yellow for easy identification by German pilots who might mistake it for an enemy aircraft during flight operations. The propeller was painted yellow, and a red band adorned the nose of the engine cowling. In accordance with standard Luftwaffe identification procedures for captured aircraft, this Thunderbolt was destined for service in the Wanderzirkus Rosarius, Rosarius's traveling circus. Here, it would force German fighter pilots to confront an uncomfortable reality about American engineering skill, industrial capacity, and their own increasingly untenable tactical situation in the worsening air war over Europe. The story of how captured enemy aircraft became revelatory tools for the Luftwaffe did not begin with Henderson's emergency landing, but with the escalating air war over Europe and the urgent need for accurate, systematic intelligence on the capabilities of Allied aircraft that went beyond disjointed combat reports. By mid-1943, the Luftwaffe faced a strategic crisis that threatened to cripple Germany's air defense. American bomber formations were penetrating deeper into the Reich each month, protected by fighter escorts whose true capabilities remained a mystery to German commanders. Intelligence reports from fighter pilots often contradicted each other and reflected the chaos of air combat rather than systematic analysis. Hetman Theodor Rosarius, an experienced Luftwaffe officer, understood that German combat units needed practical experience with captured enemy aircraft, opportunities to fly these planes under controlled conditions, and systematic evaluation to discover their strengths and weaknesses. In 1943, Rosarius established the Wanderzirkus Rosarius, officially the 2nd Squadron of the Luftwaffe High Command's Experimental Command, Versuchsverband Oberkommando der Luftwaffe. This unit received all repairable Allied aircraft. The unit's mission went beyond simple static testing. Rosarius organized traveling demonstrations where captured aircraft would visit active Luftwaffe fighter bases, allowing frontline pilots to examine these planes up close, observe them perform aerial demonstrations, and in carefully selected cases, fly simulated combat missions against them. The program addressed a fundamental problem in pilot training, which was that German pilots trained primarily against their own aircraft, creating a dangerous blind spot when confronting Allied pilots whose aircraft possessed distinctly different performance characteristics. The recovery of Allied aircraft had become highly systematized by 1944. Specialized German salvage teams worked with considerable efficiency to secure crash sites, assess damage, and transport repairable Allied aircraft to centralized testing and repair facilities. The sheer scale of Allied air operations over Europe made captures inevitable. Thousands of monthly sorties by American and British forces resulted in numerous emergency landings on German-controlled territory. Some pilots made controlled emergency landings that left their aircraft nearly intact, sometimes with only minimal structural damage that could be repaired. Henderson's P-47 fell into this category of repairable aircraft. The aircraft had been damaged during intense fighter sweeps, forcing an emergency landing on territory still under German control. German salvage teams arrived at the scene within hours, examining the Thunderbolt carefully, assessing the extent of the damage, and determining that the airframe was still sound enough for repair and restoration to flying condition. The aircraft was carefully loaded onto a specialized transport vehicle and sent to Rechlin. The Rechlin Test Center served as the Luftwaffe's primary facility for evaluating new German aircraft designs and conducting detailed testing of captured enemy types. The technicians at Rechlin possessed considerable skill in reverse engineering and repairing Allied aircraft despite the lack of original technical manuals and authentic spare parts. The process of repairing Henderson's Thunderbolt required considerable ingenuity and resourcefulness, speaking to both German technical competence and the growing challenges of working with limited resources. The technicians salvaged parts from other downed P-47s recovered across Europe, building a stock of spare parts to create a single flyable aircraft from multiple damaged ones. The Pratt & Whitney R2800 double Wasp engine, a powerful 18-cylinder radial engine producing over 2,000 horsepower, underwent detailed inspection and necessary repairs. This engine represented a significant technological achievement, providing great power and high durability. The aircraft's 8.50 caliber Browning M2 machine guns, mounted 4 per wing, were removed and replaced with ballast weights to maintain proper weight distribution and center of gravity, as German regulations prohibited arming captured aircraft used for testing and demonstration purposes. After weeks of meticulous work, the Thunderbolt was declared ready for initial test flights. German test pilots approached their first encounters with the captured P-47 with a professional curiosity mixed with considerable skepticism, born from years of Luftwaffe propaganda. Official information had consistently portrayed American aircraft as crude machines that prioritized quantity over quality. These comfortable assumptions began to unravel quickly as soon as experienced German test pilots climbed into the Thunderbolt's cockpit and experienced firsthand what American designers and engineers had truly achieved. The P-47's cockpit layout immediately impressed the German pilots. Although much larger than the Bf-109, the Thunderbolt's cockpit demonstrated a thoughtful ergonomic design, with logically arranged controls placed within easy reach, reducing pilot workload. The seat offered significantly more comfort than in German fighters, a critical factor on missions lasting several hours. The visibility from the bubble canopy, a feature of later P-47D variants, was superior to what Bf-109 pilots experienced. But the real revelation came when German test pilots advanced the throttle and felt the Pratt & Whitney R2800 engine respond with a thunderous roar. The power came on smoothly and predictably as the Thunderbolt accelerated down the Rechlin runway. The 4-bladed propeller, or sometimes 3 or 5 depending on the variant, bit effectively into the air. The takeoff roll was significantly shorter than expected for an aircraft of the P-47's weight and size, a clear testament to the engine's considerable power and the airframe's robust aerodynamic design. Once airborne, the Thunderbolt displayed handling characteristics that fundamentally challenged everything German pilots thought they understood about American aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized, providing good feedback without becoming overly heavy at high speeds, and lightning smoothly at lower speeds without becoming overly sensitive. The Thunderbolt responded crisply and predictably to control inputs. Its roll rate was very good, allowing for rapid changes in direction, which was crucial for both offensive and defensive maneuvering in combat. German test pilots systematically evaluated the Thunderbolt's performance through carefully planned test flights. The P-47's climb performance, particularly at medium and high altitudes, was considerably impressive. The powerful R2800 engine with its efficient turbo-supercharger continued to produce significant power even as the air grew thinner at altitude. something German fighters equipped with single-stage superchargers struggled with. The high-altitude performance was particularly significant for German pilots and tacticians because American bomber formations often operated at altitudes between 25,000 and 30,000 feet. This revelation was a sobering one for pilots and commanders. The Thunderbolt could not only escort bombers to these altitudes, but could also fight effectively there, maintaining a speed and maneuverability advantage. Speed trials conducted under controlled conditions at various altitudes confirmed the Thunderbolt's impressive speed. The P-47D could reach approximately 420 to 430 miles per hour at its optimal altitude. While it might have been slightly slower than the Mustang at extreme altitudes, at typical combat altitudes, the Thunderbolt was a formidable opponent. This speed advantage proved tactically decisive in combat, allowing P-47 pilots to dictate the terms of engagement. The P-47's thick, powerful wing design, while not a laminar flow like the Mustangs, provided structural strength and high load carrying capacity, a major advantage in high-intensity engagements and when carrying heavy ordnance. This wing maintained its effectiveness over a wide speed range, providing consistent, predictable handling characteristics. Dive performance revealed another area where the Thunderbolt demonstrated clear superiority. The aircraft could dive at very high speeds without experiencing severe control stiffening or a loss of control effectiveness. Pilots could pull out of steep, high-speed dives without excessive physical effort, and the airframe remained stable throughout the maneuver. This capability was especially important as the P-47 often employed effective boom and zoom tactics. The P-47's turning performance, while not its strongest point compared to lighter fighters like the Bf-109 in a tight, sustained low-speed turning fight, was more than compensated for by its superior speed, climb rate, and structural strength. P-47 pilots learned to use energy tactics, efficiently converting speed into altitude and vice versa, allowing them to control the engagement. The structural strength and rugged construction of the Thunderbolt impressed German engineers. The aircraft was built extremely tough, with significant safety margins designed into critical structural components. This robust construction philosophy contrasted sharply with German design practices that often sacrificed durability for weight savings. The P-47 could absorb significant combat damage and still successfully return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. The American engineering philosophy clearly emphasized survivability and maintainability. The P-47's range capability, while initially limited compared to the Mustang, was significantly improved with the addition of external drop tanks, allowing it to escort bombers deep into Germany. Its persistence in the ground attack role was also not to be underestimated, carrying an impressive bomb and rocket load. German pilots who flew captured Thunderbolts consistently reported being enormously impressed by the aircraft's robustness and endurance. The flight controls, while perhaps a bit heavy at high speeds, still allowed the pilot to fly with precision. The accessibility for maintenance surprised German ground crews. The Thunderbolt's engine cowling opened up in multiple sections, providing excellent access to the large radial engine and its auxiliary systems. The overall design clearly reflected the American emphasis on rapid repair and high operational readiness. The Wanderzirkus Rosarius took the captured and repaired Thunderbolt, bearing the code T9+FK, on an extensive tour of Luftwaffe fighter bases throughout late 1944 and early 1945. At each stop, demonstrations showed German pilots exactly what Allied aircraft could do in the air, and taught them specific tactics to counter Allied strengths. The demonstrations often began with the captured aircraft taxiing past German pilots and ground personnel, creating surreal scenes as enemy aircraft with German markings moved among German fighters. This was followed by flight demonstrations where experienced German test pilots would put the captured aircraft through aerobatic maneuvers and tactical drills, showcasing specific performance capabilities. For the Thunderbolt demonstrations, test pilots would perform high-speed passes at medium altitudes and powerful dives to demonstrate the aircraft's attack capabilities. They would perform climbing maneuvers to display climb performance and high-altitude capability. Simulated dogfights against German fighters would illustrate both the Thunderbolt's strengths and the limited circumstances where German fighters still held an advantage. The simulated combat sessions were sobering for German pilots, who had been led to believe that their aircraft and tactics were still quite competitive. Directly observing and experiencing the Thunderbolt's operational capabilities in dynamic combat maneuvers clearly demonstrated that American pilots flying the P-47 possessed significant tactical advantages, particularly at medium altitudes and when using energy tactics. This pattern of revelation and dawning realization repeated itself across numerous Luftwaffe bases. German pilots received official assurances of the superiority or parity of their aircraft, then experienced actual combat and live flight demonstrations that directly contradicted those optimistic assessments. The captured aircraft demonstrations provided concrete, undeniable evidence that German fighters faced formidable opponents. The program achieved mixed results by late 1944 as Germany's strategic situation deteriorated. Although the demonstrations provided valuable tactical intelligence, this knowledge could not overcome the fundamental and growing disadvantages faced by German forces. The Luftwaffe suffered from a severe fuel shortage, limiting training flight hours for new pilots. Experienced pilots became increasingly scarce due to losses in the brutal air battles of 1944. Aircraft production could not replace losses fast enough. Most importantly, the revelations from captured aircraft were often more demoralizing than inspiring, as pilots realized the extent of their disadvantage. German pilots clearly recognized that they were flying inferior aircraft, or at least inferior in the performance categories most critical for the missions they were assigned. The P-47's incredible speed, endurance, and payload capacity could not be matched by any German fighter in service. The technical intelligence gathered from captured Thunderbolts extended beyond simple flight testing and combat evaluation. German engineers dismantled P-47 components to understand American manufacturing techniques, material choices, and detailed design methods. They examined the wing structure and airfoil sections meticulously, studying construction methods. They analyzed the Pratt & Whitney R2800 engine with great interest, noting its sophisticated turbo-supercharger system that enabled impressive high-altitude performance. The fuel and hydraulic systems were also evaluated. German engineers consistently noted the high quality of materials used throughout the aircraft. America's access to strategic materials like high-grade aluminum alloys, specialized steels, and reliable rubber compounds allowed designers to create structures that efficiently combined strength with acceptable weight while maintaining production efficiency. Germany faced increasingly severe material shortages by 1944, forcing the use of substitute materials that were often inferior in strength, durability, or manufacturing characteristics. The investigation of captured Thunderbolts revealed sophisticated manufacturing techniques that allowed for true mass production without significantly compromising quality standards. American factories produced P-47s using highly developed assembly line methods, maintaining extremely tight tolerances and consistent quality across thousands of individual aircraft. The captured Thunderbolt, with the code T9+FK, served with the Wanderzirkus Rosarius until late 1944 or early 1945. Historical records do not clearly establish whether the aircraft crashed during a demonstration flight, was destroyed on the ground during an Allied air raid, or fell victim to other circumstances of war. By that point in its second operational life, the aircraft had traveled throughout Germany, visiting numerous Luftwaffe bases and providing direct practical knowledge to hundreds of German pilots about the capabilities of American aircraft. Other captured Thunderbolts served similar evaluation and demonstration roles for the Luftwaffe. German records and post-war research indicate that at least 2 P-47s were definitely operational with the Wanderzirkus Rosarius at various times during 1944 and early 1945, bearing the Luftwaffe codes T9 plus FK and T9 plus PK, although T9 plus PK was later identified as a captured Lavochkin La-5FN. The transfer of this tactical knowledge to Germany's allies reflected the recognition that the Thunderbolt represented a significant and growing threat that required specialized counter-tactics that needed to be widely disseminated. The broader implication of German pilots directly experiencing and thoroughly understanding superior American fighter aircraft extended beyond immediate tactical considerations. The Thunderbolt represented tangible, irrefutable proof that American industrial and engineering capabilities were on par with or superior to German achievements in critical areas, contradicting years of propaganda about American industrial and technical inferiority. This uncomfortable realization challenged fundamental assumptions about relative national capabilities and contributed significantly to the decline in morale among German pilots, who increasingly understood that they fought at a severe and growing disadvantage that no amount of skill, courage, or tactical wisdom could entirely overcome. The Thunderbolt's range capability, combined with the Mustangs, particularly alarmed German commanders as they clearly recognized the decisive strategic implications. The bomber war over Germany, which had seemed containable when Allied escort fighters had limited range, became unstoppable once the P-47 and Mustang could provide continuous escort throughout the entire mission. Production numbers told a devastating story of relative industrial capacity. By late 1944, American factories were producing hundreds of P-47s per month. This output was more than double the combined production rate of all German single-engine fighter types. Furthermore, these Thunderbolts were equipped with reliable engines built to consistent quality standards, sophisticated and precise instruments and radio equipment that actually worked consistently and reliably. The quality and thoroughness of American pilot training also became increasingly apparent through engagements analyzed by surviving German pilots. American pilots typically arrived at operational units with 200 to 400 total training flight hours. German pilot training had been dangerously and significantly curtailed by late 1944 due to the severe fuel shortage. New pilots sometimes arrived at frontline units with less than 100 total flight hours, little combat training, and often no instrument flight training at all, leaving them dangerously unprepared for the realities of combat operations. These undertrained pilots faced veteran American pilots flying objectively superior aircraft, a combination that produced grimly predictable results reflected in German loss statistics. German loss rates among fighter pilots rose dramatically and unsustainably during 1944 and early 1945. The Wanderzirkus Rosarius demonstrations revealed these harsh realities directly to German pilots before they encountered them in actual combat. While this advanced preparation theoretically improved their chances of survival by providing a realistic understanding of what they would face, it also made painfully clear the deteriorating situation that German forces faced on all fronts of the air war. Some German test pilots who flew the P-47 extensively developed a grudging professional respect for American engineering skill and design philosophy. They recognized through direct experience that the Thunderbolt represented a coherent, well-integrated design that intelligently prioritized the characteristics most valuable for its intended strategic mission of medium-range escort and ground attack. The aircraft was designed to withstand damage and carry a heavy weapon load, befitting its role as the Jug. The Thunderbolt's ease of production also impressed German engineers. The aircraft's design facilitated true mass production through modular construction, standardized parts, and design features that simplified assembly operations. American factories could produce Thunderbolts in huge numbers while maintaining consistently high quality. The Pratt & Whitney R2800 double Wasp engine represented another critical area where American capabilities surpassed German achievements. This engine proved reliable and relatively easy to maintain under field conditions. The psychological impact on German pilots, who came to thoroughly understand through direct experience the performance gap they faced, cannot be overstated. These men had entered the war with a belief in their superior training, the capabilities of their aircraft, and the effectiveness of their tactical doctrines. By late 1944, extensive combat experience and direct exposure to captured Allied aircraft had systematically eroded that confidence. Former Luftwaffe pilots and post-war interviews from this period often describe a sense of hopelessness at seeing formations of American fighters appear on the horizon, and knowing that those escorts could not be avoided by any tactical maneuver and could not be outrun by any German fighter in service. German pilots understood that engaging a Thunderbolt or a Mustang at high altitude meant fighting at a severe disadvantage. The Wanderzirkus Rosarius program continued to operate as long as was practically possible, conducting demonstrations with various captured aircraft. As Allied forces advanced deeper into Germany, the unit's ability to safely travel to operational bases to conduct demonstrations diminished. Eventually, the program was forced to cease operations as the general collapse of the German military organization enveloped even specialized units like testing and evaluation groups. The knowledge gained from the systematic testing of captured Thunderbolts provided German pilots with valuable tactical intelligence. But this knowledge ultimately could not overcome the fundamental and overwhelming disadvantages the Luftwaffe faced by 1944. The testing and demonstration program represented a sophisticated and systematic attempt to counter Allied advantages through tactical innovation and improved pilot knowledge. But tactics and knowledge alone could not compensate for inferior aircraft performance, severe numerical disadvantages, inadequate training due to fuel shortages, and a lack of replacement parts and experienced maintenance personnel. Captain Thomas Fraser's P-47D-11RE, serial number 4226639, had an extraordinary life after its emergency landing. From a downed fighter lying in a field, it became a revelatory tool for German pilots, demonstrating concretely American engineering capabilities and forcing an acknowledgement of Allied air superiority that no amount of propaganda could overcome. The experience of German test pilots confronting the Thunderbolt's capabilities and coming to terms with American engineering achievements paralleled the broader German military experience in the later stages of World War II. Initial belief in German technological superiority and tactical innovation gradually gave way to the realization that Allied forces possessed decisive advantages in many critical areas. Vast industrial capacity, access to strategic resources, huge manpower reserves, and increasingly sophisticated technological capabilities matched or exceeded German achievements. The Thunderbolt represented a particularly clear expression of these Allied advantages. American designers had created an aircraft that excelled at its intended strategic mission of medium-range escort and ground attack. American industry produced it in enormous numbers with consistent quality despite the complexity of the design. American training programs thoroughly prepared pilots to get the most performance from the aircraft in combat. The technical sophistication of the P-47 challenged and ultimately shattered German assumptions about American engineering capabilities. Official information had portrayed Americans as capable of producing simple, rugged equipment in large quantities, but as fundamentally incapable of sophisticated design that required engineering excellence. The Thunderbolt proved definitively that American engineers could create elegant, effective designs that matched or exceeded German capabilities in strategically critical areas. The Pratt & Whitney R2800 double Wasp engine demonstrated the American ability to produce complex, high-performance engines in large numbers and with consistent quality. The integration of the aircraft's systems reflected sophisticated engineering that successfully balanced multiple competing requirements to create a coherent, effective weapon system optimized for its intended mission. German pilots who flew the Thunderbolt extensively could not honestly dismiss American engineering as crude or unsophisticated based on propaganda. They directly experienced an aircraft that handled beautifully throughout its flight envelope, performed excellently in its strategically critical mission profile, and demonstrated thoughtful, competent design in every system. The strategic bombing campaign over Germany succeeded in large part due to the unique combination of capabilities of the P-47 Thunderbolt and the P-51 Mustang. Previous Allied escort fighters like the Republic P-47 Thunderbolt and the Lockheed P-38 Lightning, while capable in other areas, had insufficient range to escort heavy bombers throughout their entire missions to targets deep inside Germany and back to bases in Britain. This critical limitation allowed German fighters to simply wait until the escorts reached their fuel limit and turn back to their bases before attacking the bomber formations during the most dangerous parts of their missions. The resulting unsustainable bomber losses forced a suspension of deep strike raids. The Mustang and long-range variants of the P-47 fundamentally changed bomber escort operations by providing continuous, effective fighter protection throughout the entire mission, regardless of target distance. German engineers created detailed technical reports documenting all findings, directly comparing the P-47's performance to German fighter types under equivalent conditions, and analyzing specific design features that contributed to the observed performance. These technical reports were circulated within German aviation circles, informing aircraft designers of Allied engineering methods, providing tacticians with accurate performance data for operational planning, and giving operational commanders realistic assessments of Allied capabilities for use in tactical decision-making. The reports confirmed what fighter pilots were reporting from actual combat engagements. The Thunderbolt possessed significant and decisive performance advantages in the categories most critical for its strategic mission. The systematic analysis highlighted the aircraft's exceptional durability, its ability to carry a heavy payload for ground attack missions, its reliable performance at medium and high altitudes thanks to its powerful turbo-supercharged engine, its high top speed that provided tactical flexibility, and its well-harmonized handling characteristics that reduced pilot workload and allowed for effective combat maneuvering. Germany initiated several ambitious fighter development programs in 1944, specifically aimed at countering Allied air superiority through advanced technology. However, severe material shortages, production delays caused by Allied bombing, and resource constraints, and the rapidly deteriorating overall war situation prevented these advanced designs from entering service in sufficient numbers to affect the strategic outcome or reverse Allied air superiority. The jet-powered Messerschmitt Me-262 represented Germany's most successful attempt to leapfrog Allied piston engine fighter performance through pioneering jet propulsion technology. The Me-262 possessed significant speed and firepower advantages that made it extremely dangerous to Allied bombers when flown by skilled pilots who understood how to exploit its capabilities. However, the type suffered from chronic engine reliability problems that limited its operational availability, required large concrete runways vulnerable to Allied attack, consumed large quantities of increasingly scarce aviation fuel, and appeared too late and in too few numbers to change the strategic outcome or seriously threaten Allied air superiority. Even the Me-262's impressive technological advantages proved strategically insufficient to overcome the overwhelming numerical superiority of the Allies and the collapsing infrastructure, fuel supplies, and pilot training programs of the Luftwaffe.
The final year of World War II in Europe saw the systematic disintegration of the Luftwaffe as an effective fighting force capable of meaningful resistance. Catastrophic pilot losses, severe and worsening fuel shortages, production difficulties caused by Allied bombing, and overwhelming Allied numerical superiority combined to render Germany's air defenses increasingly ineffective, regardless of the skill or courage of individual pilots. The captured aircraft testing program continued to operate as long as was practically possible, attempting to provide tactical intelligence that might improve the survival chances of German pilots even as the strategic outcome became inevitable and final defeat loomed. German pilots who had flown captured Thunderbolts extensively and understood the capabilities of Allied aircraft faced the end of the war with complex and mixed emotions. Professional airmen appreciated the engineering achievements represented by aircraft like the P-47, even while regretting their service on the losing side of history's most devastating war. Many had no illusions that Germany's defeat would be anything other than total and unconditional. Having witnessed firsthand the overwhelming material advantages possessed by Allied forces in every aspect of military power, the captured Thunderbolt testing program represents a fascinating and instructive chapter in the history of World War II aviation, illustrating how professional military organizations attempt to understand and counter an adversary's advantages through systematic intelligence gathering, even in the most desperate circumstances. The program provided tactically valuable knowledge to German pilots through direct experience with captured aircraft. But this knowledge ultimately could not overcome the fundamental imbalances in industrial capacity, resource access, technological capability, and trained manpower that characterized the air war in 1944 and 1945. German forces fought with incredible courage, impressive tactical skill, and professional competence, but faced an adversary whose superior resources, better equipment, more thorough training, and an advantageous strategic position proved decisive. The admission by German test pilots that they had never encountered handling characteristics like those demonstrated by the Thunderbolt represented a professional acknowledgement of American engineering achievement and a realistic recognition of the significant performance gap that German pilots faced in combat operations. This admission, driven by direct experience rather than propaganda or second-hand intelligence reports, illustrated how confronting uncomfortable realities sometimes requires direct personal experience that cannot be dismissed or explained away by wishful thinking or ideological assumptions. The legacy of the Wanderzirkus Rosarius and similar programs lies not just in their immediate tactical impact, but in their demonstration of the value of systematic intelligence gathering, professional competence in technical evaluation, and honest assessment of an enemy's capabilities even under the most difficult strategic circumstances. In the final chaotic months of the war, the operations of the Wanderzirkus Rosarius became increasingly untenable. Relentless Allied air raids turned German airfields into perilous targets, and a crippling fuel shortage grounded even the most critical flights, let alone demonstration sorties. The Zirkus's aircraft, including the Thunderbolt T9 plus Fk, were largely confined to their home bases, unable to tour frontline units as they had before. The collapse of the Western and Eastern fronts in early 1945 meant that many of the bases the Zirkus had once visited were now either in Allied hands or on the front lines themselves. As Allied armies pushed deep into German territory from all directions, an order was issued throughout the German military: destroy all sensitive equipment, advanced technology, and valuable intelligence assets to prevent them from falling into enemy hands. The Wanderzirkus Rosarius's unique collection of Allied aircraft certainly fell into this category. Historians believe that most of the unit's planes, likely including P-47 Thunderbolt T9 plus Fk, were destroyed by the Germans themselves in April or early May of 1945. They were likely blown up, set on fire, or otherwise systematically wrecked to ensure they could not be examined or flown again by the advancing Allies. Due to the chaos of the war's final days, detailed records of the disposal of each individual aircraft were lost, leaving the precise fate of Henderson's P-47 shrouded in mystery, though its destruction remains the most probable outcome. The fate of the key figures. Theodore Rosarius, the man behind this unique program, survived the war. His extensive expertise on Allied aircraft was highly valued by the victorious powers. After his capture, he was debriefed extensively by the British as part of Operation Surgeon, a British intelligence effort to exploit German scientific and technical knowledge. Rosarius provided valuable insights into the Luftwaffe's assessments of Allied aircraft, confirming many of the conclusions that Allied analysts had reached on their own. His experience served as a testament to the principle that a thorough understanding of an enemy's capabilities is a fundamental aspect of modern warfare. Captain John "Crash" Henderson, the American pilot whose fateful day in December 1943 began this extraordinary story, spent the remainder of the war as a prisoner of war. He was held at Stalag Luft I, a German POW camp specifically for captured Allied airmen. He endured the harsh conditions of prison life until the camp was liberated by Soviet forces in May 1945. Like thousands of other Allied airmen, his sacrifice included the loss of his freedom, while the very machine he had flown took on an improbable second life in the hands of the enemy. Legacy and conclusion. The story of P-47 Thunderbolt T9 plus Fk and the Wanderzirkus Rosarius serves as a fascinating and illuminating side chapter in the broader history of the air war in World War II. It underscores a fundamental truth. In a technological war, the hardware itself tells a story that propaganda cannot conceal. For the Luftwaffe panics, raised on tales of German technical superiority and American crudeness, the first-hand experience of the Thunderbolt was a brutal awakening. The aircraft was more than just a machine. It was a physical manifestation of American industrial might, design philosophy, and engineering prowess. It proved that the Americans could build a plane that was not only mass-produced, but also powerful, durable, high-performing, and sophisticatedly engineered. Every aspect of the Thunderbolt, from its mighty double Wasp engine to its ergonomic cockpit and rugged construction, spoke to a reality the German High Command was unwilling to admit, that they faced an enemy who could match or surpass them in the very fields once considered a German monopoly. In the end, the Wanderzirkus Rosarius did not change the outcome of the war. The knowledge it imparted, while tactically valuable, could not overcome the overwhelming disparities in numbers, resources, and industrial production. The program remains, however, a remarkable example of military intelligence in practice. It represented a rational and systematic attempt to understand the enemy, not through disjointed reports or boastful claims, but by directly, physically experiencing their technology. The legacy of the captured Thunderbolt reminds us that underestimating one's opponent is a fatal error. For the hundreds of German pilots who saw, heard, and flew against T9 plus Fk, the Jug, bearing German crosses, delivered an unforgettable lesson in the reality of the war and the formidable power of the industrial and engineering machine that ultimately overwhelmed them. Its story is not about a single aircraft, but about the collision of two industrial and technical systems, a confrontation whose outcome was decided not only on the battlefields, but in the factories, design bureaus, and testing centers where these machines of war were born.